All right, we're going to finish up 4.7, and this is over logarithmic scales or logarithmic formulas. So word problems involving logarithms. So I'm going to front load this here with all the formulas that you would need for this section. The first one is pH scale. And pH is a measure of how acidic or how basic a substance is. And that would be pH equals negative log H plus, where H plus or H positive is your concentration of hydrogen. Okay, and for pH, 7 is kind of your neutral number. As we get higher in numbers, it becomes more basic. And as we get lower in numbers, it gets more acidic. Okay, it becomes more of an acid than a base. For example, a lime has a pH of about 1.3, 1.4, 5, somewhere in there, and that is very acidic. Okay, the next one is a Richter scale. And the Richter scale is the magnitude of an earthquake. So that is measured as M equals log I over S. And sometimes we use I not down here. It just depends on the author. So I is the intensity. And S is the standard intensity. Which that standard intensity is 10 to the negative fourth. Okay, and that is what we measure here on Earth, what we measure, or at least in the US, what we measure earthquakes from. Okay, and the last one here is decibel level. And decibel deals with sound. So dB, or just B is what they use sometimes, is 10 log I over I naught, where I is still the intensity, and I naught would be your standard intensity. Which for humans, that is 10 to the negative 12. Okay, that standard intensity is the intensity of a just barely audible sound. Okay, so the lowest kind of thing that you can hear. It's what we measure the intensity from, or the decibels from. Okay, so this first problem, the hydrogen ion concentration of a sample of human blood was measured to be 3.16 times 10 to the negative 8 moles. Find the pH and classify the blood as acidic or basic. Okay, so we're using this formula, pH equals negative log H plus. Okay, and they give us the H plus. So here on A, we're trying to find the pH. So negative log of 3.16 times 10 to the negative 8. Okay, and then we're just going to take that and plug it into our calculator. So if I switch here, switch screens maybe to my calculator. Okay, so we're going to have here, there's an EE button right here. And so second comma, and that would give us our scientific notation. So we have, let me kind of move this so we can see it. So we have negative log of 3.16. And if I hit the EE right there, that E stands for times 10 to the, and then we'll put -8. And then sometimes it will spit back in scientific notation, so just know that. So this pH level of human blood was 7.5, okay, which in this case is more basic than acidic because it's closer to, it's higher than 7. The most acidic rainfall ever measured occurred in Scotland in 1974. Its pH was 2.4. Find the hydrogen ion concentration. So now we're setting it equal to 2.4, negative log of H positive, and we're solving for H positive. So first I got to divide by -1. So that's -2.4 equals log of H positive. And then I need to get this out of logarithm, which takes to the base 10. So you have 10 to the -2.4 equals H positive. Okay, so this is not in scientific notation. So 10 to the -2.4. Okay, and usually hydrogen positive is in scientific notation. This is not right here. Okay, so we have, if we change this to scientific notation, that's 1, 2, 3. So that would be times 10 to the -3. And this actually goes to 4.0 if you round it. So this would be 4.0 times 10 to the -3 moles. Okay. All right, looking at our next one here. Find the magnitude of an earthquake that has an intensity of 3.75. That is the amplitude of the seismograph reading is 3.75. So we're using the Richter scale. Magnitude equals log I over S. They give me the intensity here. And we know that the standard intensity is 10 to the -4. So we have M equals log of 3.75 over 10 to the -4. Okay, again, we'll just put that into the calculator. So we'll have log of 3.75 over 10 to the -4. So 4.6. So this earthquake would be a 4.6 on the Richter scale. Okay, and here it talks about the amplitude of the seismograph reading is 3.75. Okay, a seismograph machine, if you don't know what that looks like, from the side here, it's just like a little cylinder in a box. Now they're digital. And then it had a little lever or a little arm here that sat on top of the drum. So from the top view, it looked like this. You had like a little drum right here, cylinder that rotated, and then you had this arm that came out here, and this arm moves back and forth, okay, as the earthquake happens, or as the earth moves, that arm moves back and forth. And what this is saying is that the amplitude of that arm moving was 3.75 centimeters. So that's how they measure intensity for those. Part B, an earthquake was measured to have a magnitude of 5.1 on the Richter scale. Find the intensity. So now we have that the amplitude or the magnitude was 5.1, and we need to find the intensity of this thing. So first we need to get it out of logarithmic form. So that's 10 to the 5.1 equals I over 10 to the -4. and then we'll multiply by 10 to the minus 4. Those cancel, so you get I equals, and these bases are the same, so we would add the exponents. So that's 10 to the 1.1, and 10 to the 1.1 is about 12.59, which means that this needle over here, on the first one, it was just moving 3.75 centimeters. Now this amplitude is 12.59 centimeters. So that's moving up. That's 4 times, almost 4 times as much movement there in the intensity. The 1906 earthquake in San Francisco had an estimated magnitude of 8.3 on the Richter scale. In the same year, a powerful earthquake occurred in the Colombia-Ecuador border that was 4 times as intense. What is the magnitude of the earthquake on the Richter scale? So we know here that the San Francisco one had a magnitude of 8.3 on the Richter scale. So that'd be log I over 10 to the negative 4. The Colombia, Ecuador earthquake had an intensity of 4 times this. So what we could do is we could solve this for I. Okay, so we could solve this for I and say 10 to the 8.3 equals, and that canceled my log, I over 10 to the negative 4, and then multiply by 10 to the negative 4. So I equals 10 to the negative 4 times 10 to the 8.3. I'm going to leave it like that because the Colombia-Ecuador intensity was 4 times this. And I want to know its magnitude. So what is it on the Richter scale? If its intensity was 4 times that of this one. So 4 times 10 to the negative 4, 10 to the 8.3 over 10 to the negative 4. Okay, now here our 10 to the negative 4s cancel. We have log of 4 times 10 to the 8.3, which if we do that on the calculator here, you get about 8.9. So that had a magnitude of 8.9 on the Richter scale. Okay, the 1989 earthquake that shook San Francisco had a magnitude of 7.1 on the Richter scale. How many more times intense was the 1906 earthquake than the 1989 earthquake? So we want to look at the intensities of each one. So we know that the 1906 earthquake was 8.3 right here. 8.3 was that magnitude. 8.3. And we need to find the intensity of this one. So 7.1 equals log I over 10 to the negative 4. Okay, so that's 10 to the 7.1, which is, that cancels your log, and you get I over 10 to the negative 4. And then multiply by 10 to the negative 4. So 10 to the negative 4 times 10 to the 7.1 equals the intensity. Okay, so this is the intensity of the 1989. So we want the intensity of the 1906 over the intensity of the 1989. So the intensity of 1989 was 10 to the negative 4, 10 to the 7.1. If we look back, we know that 8.3 was kind of the magnitude. So that would be 10 to the negative 4, 10 to the 8.3. And I'll show you here. That intensity was right here. Okay. Well, with this, your 10 to the negative 4s cancel. Okay, so you have 10 to the 8.3, 10 to the 7.1, and those are the same base, so you subtract. So you have 10 to the 8.3 minus 7.1, which is 10 to the 1.2, which is about 16. So that means that this the 1906 was 16 times more intense than the 1889 earthquake. And just be careful with the way this is written and how you set this ratio up. If it doesn't make sense, just flip it over. We know that the 1906 was higher on the Richter scale than 1989 earthquake. So it needs to be kind of bigger than 1. Your bigger number needs to go on top. Decibel level. So find the decibel level of a jet engine at takeoff if the intensity was measured in 100 watts per meter squared. So your decibel level, so dB equals 10 log of I over I naught. And this I naught we said was 10 to the negative 12 for human ears. Okay, so its intensity was 100. So dB equals 10 log of 100 over 10 to the negative 12. Okay, and you shouldn't need a calculator for this. Okay, so you have 10 log of 10 squared over 10 to the negative 12. Your bases are the same, so we're going to subtract these. So you have 10 log 10 to the 14th. Your log has a base 10, cancels your exponential with base 10, so you have 10 times 14 now, which is 140 dBs, 140 decibels. With this last one, find the intensity level of a motorcycle engine at full throttle if the decibel is measured at 90. So we know that it equals 90. Oop, that's a 10. 10 log I over 10 to the negative 12. Okay, so first we're going to divide by 10. That's for this 10. So you get 9 equals log I over 10 to the negative 12. Change it to exponential, so that's 10 to the 9th equals I over 10 to the negative 12. Multiply both sides by 10 to the negative 12. That cancels there. You have 10 to the 9th times 10 to the negative 12. We add those exponents. So that'd be 10 to the negative 3rd equals I, which is 1 over 1,000 or 0.001. Okay, so just pay attention however they want their answer. They may say, if not, then you get to leave it however you want. All right, that's 4.7. If you have questions, make sure you're reaching out and getting those answered.